In this video, we're going to learn how to calculate fine dead fuel moisture values. In order to calculate fine dead fuel moisture values of our 1 hour fuels, or 1/4 inch or less in diameter, we need several things. First, we need to determine a reference fuel moisture value. This takes into account dry bulb temperature and relative humidity. We also need a fuel moisture correction value. This takes into account the month of the year, whether the fuels are shaded or unshaded, the time of day, the elevation of the fuels, aspect, and slope. Once you have these two values, you can add them together and you get your fine dead fuel moisture. This is a fine dead fuel moisture worksheet. This can be found in the Appendix B. This is where we're going to keep track of our inputs and outputs. This is Table 2. This is where we determine our reference fuel moisture using relative humidity and dry bulb temperature. This is found in the Appendix B on page B25. This is Table 3. This is one of 3 tables designed to find your correction values. You can see they have aspect, slope, time of day. The top half is for shaded fuel or unshaded fuels, and the bottom half is for shaded fuels, all giving you different values. There's also multiple columns for each time range. One for below, level with, or above. We'll explain this here in a minute. Table 4 is for a completely different set of months. Where the first table was for May, June, and July, this table is for February, April, August, and October. The difference in the table is because of the angle of the sun and the amount of direct solar heating that the fuels will get at different areas and different aspects. The final table is for November, December, and January. So back to that above location or below. We learned in other units that temperature goes up and down with elevation because of air pressures. So if the site that you took your weather observations is level with or within 1,000 feet above or below where you took your weather, then you don't have to do any corrections and you'll use the column marked L. If the site where you took your weather is below the fire by 1,000 to 2,000 feet, you'll use the column marked A for above. If the site where you took your weather is above the fire by 1,000 to 2,000 feet, you're going to use the B column. If you're more than 2,000 feet above or below your fire when you take your weather, you'll need to take a different weather observation. Now, let's try an example exercise. We start with Table 2, reference fuel moisture. We'll say we have a dry bulb temperature of 85 degrees. Our relative humidity is 22%, so we find the column 20 to 24%. Looking at these two columns, we get a reference fuel moisture of 3%. We'll add this to our fine dead fuel moisture worksheet. Now we need a little bit more information. We're going to have to do our fuel moisture correction value. We'll need to know the month, whether it's shaded or unshaded, the time of day, the elevation, aspect, and for this, slope doesn't matter, but in unshaded fuels, it could have a difference. Because of all this, our fine dead fuel moisture correction value is 4%. If we add all of our information in to our fine dead fuel moisture worksheet, we have a reference fuel moisture of 3%, a correction value of 4, giving us a fine dead fuel moisture of 7. Let's try one more. Now we have a dry bulb temperature of 92 degrees. We'll start again on table 2. We find the row that our temperature is in. Relative humidity of 16% would put us in this column, giving us a reference fuel moisture of 2. Now we look at our additional information for our fine dead fuel moisture correction. We find the chart for November. We'll use the top table for unshaded fuels. We'll find the column for our time. We'll need to use the A column because we are 1,500 feet above. A western aspect, and a slope that's greater than 31%. This gives us a fuel moisture correction of 3. Add that to our initial, and we get a fine dead fuel moisture of 5. This concludes our video. Now we will move on to the group exercises.